we're here with Ron Spear with Wiseco, and you stopped me and you wanted to tell everybody about the differences between forged and cast pistons. Is that it?
Yeah, we can do that for you.
Yeah.
Not a problem. So what we have here is a cast piece, okay, and cast is liquid aluminum, which is poured into a mold, set to harden, and is broken apart, okay? It is a very inexpensive way of making parts, and that's why most pistons are made with cast material. Nothing wrong with it. Works very, very well. Like I said, inexpensive. Those are its benefits, okay? If we want to step the game up a little bit and we want to go to a forged piece is, once again, it's aluminum. It's a hockey puck shape of aluminum that is heated and slammed into place by a several ton press. What that does is that changes the molecular structure from it being random in a cast piece to something that moves in one direction. Okay, think of it like grain flow. Okay,
like rainfall?
Like grain flow. Okay.
Okay.
Let's take a piece of wood as an example.
Oh,
okay?
Grain like in wood.
Yes,
okay.
Exactly. Okay. If we take a piece of wood and we turn it on its side, we try to hack our way through it. We know it takes a very long time, right?
Right.
But yet if we turn it up on its side and we hit it with the axe, we run it through there, it's easier to split, but it's extremely strong that way. Okay, same thing here. All the grain flow and molecular structure is moving in one direction, and that creates a very strong piece. Okay, unlike a random cast piece, which is just a pour. Okay, if we can make it stronger, we can make it lighter. So we can remove material and therefore change your reciprocating mass weight, change your RPM level, get the sled in this case to be more responsive or in any application. Okay, so lighter, stronger, better response time. That may also equate to horsepower as well too, as the R's go up and things change, as we all know, right? So you can see right here, just on the skirt area here, and this is just one example. I'm going to use this one because it's a little bit more exaggerated. Okay, look at the amount of material here that has to be used around the skirt area to build this up. And you can see how much material is around there, and that's how it builds its strength. It has to have enough material around the cast piece for it to hold up. Okay, look at the skirt on this piston right here.
Very
you can
thin.
See that different, right? Extremely thin. Okay, once again, we're in there hogging material out, removing material, doing some work inside the pin boss areas and things. In some applications, guys, you can actually see where we can come in here. We can actually remove material on the outside that reduces weight as well.
Right.
Okay, because we have a much stronger piece. That's really the big benefit over a forged versus a cast piece. Both work extremely well. Okay, one is much more affordable to design and build. The other one is a little bit more expensive, but there's additional properties and benefits with that.
What about heat absorption? Is that a factor?
Heat absorption is always going to be an issue inside a motor. Obviously, we want to dissipate as much heat as possible. I don't want to get into I can't really answer the differences of that per se. Okay.
Okay.
But what you're looking for here is a much more responsive piece, a much lighter and a much stronger piece. That's really it.
Longevity?
Once again, I'll say that I think that with anything, it really comes down to how clean you keep the motor.
Right.
Okay. How often do you change your filters? Okay. What type of riding conditions are you in? Are you in a powder type situation where you're ingesting snow or doing things? Or you're on hard pack? Or if you're riding an ATV or other applications, are you in mud? Are you in sand? Are you in grass or whatever? Those factors play a big hand in that. I would say keeping the motor clean does probably more to keep life going on any type of piston, and I don't know if there's a real benefit one or the other between cast and forged. If we had a 20-pound anvil here, or we put it in a press, what you would see with a cast piece, there's nothing wrong with it, it's just the differences of what we do. The more pressure we would apply to this, or when a cast piece lets go, let's say that it's going up and down in the bore, it starts to lose some of its dimensionality.
Yep.
Okay, if this catches a port, when it grabs that, it actually breaks into many, many pieces. Okay, you're picking parts out of your bottom end, and there's a lot of problems that could be associated with that. A forged piece being so much stronger, it may crack or it may lose some pieces, but it's so much more rigid, it's probably going to maintain its shape a whole lot different. So if we went back to that example, and if you guys ever want to do something on TV for that, it makes for great demonstration.
Okay.
Okay. Build a cylinder, have something come down and be the same weight, same distance of drop, and everything else. Watch what the cast piece does. Watch what the forged piece does. That answers everything you ever need to know about the difference between cast and forged. Okay? We've done it with a 10-pound weight before with the drawstring that came down, and it's not that anything is wrong or different. It's just different. That's why this is so much more economical, and that's why this is really like a piece of jewelry that has to be machined.
It is jewelry.
Okay?
There's no doubt about it.
That is it.
Well, and you know, when you're talking price point, you know, if you're comparing apples to apples, what's the difference in cost for?
We'll talk in general terms, but you know, we'll sell Canadian costs. We'll be somewhere around Adam, what about $100 to $125 a piece?
Between 125 and 135.
Okay, so 125 to 135. Same piece, if we were doing apples for a forged piece, we'd be about 150 to 175.
Yeah, about 150 to $200 depending on.
There you go.
Yeah.
Okay.
So,
Really just the machining time and the prep.
well,
that
yeah,
has to
for
come
sure.
with
I mean, that obviously takes a lot more work.
it. Yes, and then we have different skirt coatings and things. That
Yeah,
we
I was just
apply
going to say
the
there's
Wiseco.
definitely coating. What
This
about,
is,
okay, well, let's talk about coatings for a second. What is this? Years ago, we never used to see gray things on
Yeah,
it.
you'll see it all the time now.
Now, yeah.
On a cast piece, what you're going to find in the OE applications, or even in our application here, it's a break-in coating. Okay, it's going to be on for the life, not for the life of the product, for a very short period of time, and then eventually this will wear off. Okay, we use a moly-based coating on this part right here. That actually, if all things being equal, this will be on for the life of the product. It's measured in microns, and it actually helps build up some material around the cylinder bore. As we look at a cylinder bore, we know that under a microscope or in a very high-intense measuring device, it's not perfectly round. Okay, it has imperfections up and down through the cylinder there. And what we ask this to do is, as we build up material in microns, we're going to ask that to fill out the bore just slightly. Okay, it's not noticeable to our eye, but what it does is it helps that piston maintain its shape in the cylinder bore, so it prevents rocking and other things that are happening. It also takes off some of the high points that may be in the cylinder or low points, and you'll actually see that conform to the bore. And that is on for the life of the product.
So when guys pull their cylinders off and they see that some gray material is removed, it doesn't mean that the piston's worn out. It's not time to necessarily change it. It's just
Conforming to the bore.
It's conforming to the bore.
Right.
That's great to know.
Okay.
Right on.
Fantastic. Anything else I can help you with?
No, that's it. You've been very helpful.
That's what it's all about.